Okay, Ryan, what you got? Uh-huh. Yep, that's correct. Good. Yep. Yep, that's one option. Yeah, yeah. For this particular problem, there is a y in each term, so you could factor out a y first. And then look at the grouping. So you've got a y, x minus 1, x squared minus 1, or x squared minus y. Sorry. That's one way to do it. Or you could have pulled an x squared y out, minus y, x minus y squared. Yeah, x minus 1. So then you've got an x minus 1, x squared y minus y squared. But now you should see you can pull a y out of both of those. Same answer. Same answer, and either way will work. All good? All right, anyone else? Okay. I just want to, there we go. All righty then. Oh, my pens keep dying. Such is the problem with being stuck at home, I think. Okay then. And we're going to work on section 6.3. We're still going to be factoring trinomials of the form ax squared plus bx plus c. But we're going to look at some problems where we don't start out with a 1. All right, so in both of these examples, you can see that your leading coefficient or your A value is not a 1. There are two methods for doing problems like this. The first is a guess and check method. I'm not real keen on the guess and check method. What I'm going to say about that is I'm going to leave it to you to learn it if you want, but I'm not going to teach it. We have the second method, which works very nicely with everything that we did yesterday. So it's a nice sort of progression without being much more difficult. Okay, so here we go. To factor 2x squared plus 5x plus 3. We're going to multiply A times C. Since 2 is our A and 3 is our C, we're going to multiply A times C. 2 times 3 is 6. Now, this is what we're going to deconstruct. So what two numbers multiply to give you a 6, but add to give you a 5? So I'm going to deconstruct this 5x into a 3x plus 2x. This is the exact same thing we were doing yesterday. Factoring by grouping, I can look at the first two terms and pull out an x. Is there anything I can pull out of the second two terms? If that's the case, what we try to pull out is a 1. Because that won't change anything. Now I've got a 2x plus 3 here both, and an x plus 1. Questions? Oh, because yesterday this lead was always a 1. With yeah, because 1 times whatever would have been. So if we had, say, let's say we had to factor an x squared minus 8x minus 20. What's our A value here? So if I had multiplied 1 times a negative 20, so what two numbers multiply to negative 20 and add to negative 8? You sure you want a positive 10 and a negative 2? Do you want a positive 10? Do you see that it is the same thing, Ryan? Okay. It's just that our A value here is a 1, and so we didn't really think of it as A times C. But it is the same idea and process. Oh, I'm cold. What was the other one we had? What if we had to factor 6a squared minus 17a plus 5? If I multiply a by c, I get a 30. So what two numbers could multiply to 30 but add to a negative 17? And you want them positive, negative? So I've got a 6a squared and a 15. I can pull 3a out of both of those, leaving me a 2a minus 5. Here I have a negative 2a minus 5. I can't pull anything out, but the lead is negative. So I will pull out a negative 1. So I have a 2a minus 5. Since 2a minus 5 is in both terms, I have a 2a minus 5, 3a minus 1. Ooh. How are we feeling about this? Okay, Austin? Okay, I'm sorry, Summer, you were saying? Just that teensy bit more. Okay, good. I'm glad. I'm glad it goes well. All right. All right, so we can also get them with common factors, just as we have many of the others. And here we have a 2x squared minus 8x cubed plus 3x. I put this one in here because I did want to make sure that you noted that these should be in descending order. Did you see how the minus 8x to the third is actually not the first one? So as if you don't have enough to look for. Look to check that they have actually put it into descending order. Now, you've got a negative 8x to the third, a plus 2x squared, and a 3x. What can you pull out of each one of these terms? And because we're leading with a negative here now, you want to pull a negative x out, which will leave you with an 8x squared minus 2x minus 3. Now when you do a times c, you're going to do 8 times the negative 3 to get a negative 24. So what two numbers will multiply to a negative 24, but add to a negative 2? Yeah. So that's going to be an 8x squared. Is it a plus 6x or a minus 6x? Right, because I've got more negatives. And then it's got to be a plus 4x minus 3. I can pull a 2x out. 4x minus 3. I can't pull anything out of there, so I'm going to do a plus 1. 4x minus 3. So this is going to give me a negative x. I can pull that 4x minus 3 out front. And then I'm left with a 2x plus. Yeah, when you're factoring, the first step should always be to look for a common factor that you can pull out. So anytime somebody gives me something to factor, let's say we got a 12x to the 5th minus 17x to the 4th plus 6x cubed. I'm going to look for greatest common factor first. Now, a good clue that I have one is that this is a 5th, 4th, and then see how that ends with an x to the 3rd. So that's a good hint that I can actually pull out an x to the 3rd. And then once I've got that greatest common factor out, I've got a trinomial here. And that trinomial means I can use my A times C method. And if I do 12 times 6, that's 72. So what two numbers multiply to 72 but add to negative 17? Good. Those were a little bit hard to get to, weren't they? 12x squared minus 9x minus 8x plus 6. I can pull 12 and 9, I can pull a 3. X squared and x, I can pull an x. 4x minus 3. 8 and 6, I can pull a 2. Since it's negative, I'm going to lead by pulling a negative 2. 4x minus 3. Then I have an x cubed. 4x minus 3. 3x minus 2. Oh my gosh. All right, I'm still cold and I don't want to be cold. All right. Here we have a 3x squared plus 6x, or plus x plus 6. This is a trinomial. There isn't a common factor, but I can use the A times C method. That's an 18. So can you think of two factors that add to 18, I'm sorry, that multiply to 18 and add to 1? Well, but that's going to add to 17. If I write out all my factor pairs, right, I get 1 and 18, 2 and 9, 3 and 6, 4 doesn't have 1, 5 doesn't have 1, but then I'm right back to 6 and 3, so I've already used that one, so I'm done. Would any combination of these add to be a 1? No. So what does that mean, Summer? Do you remember? Correct. Again, a reminder that not everything is factorable. Just because you've now learned to factor doesn't mean that it will apply to every problem. You are still going to get problems that are not factorable. Those are called prime. I do want you to notice, though, let's do 6x to the 5th minus 3x to the 4th plus 2x squared. Oops. All right, what about this guy? You can indeed pull out an x squared. That's going to leave you with a 6x to the 3rd minus 3x squared plus 2. This is a trinomial, but it's not leading with an x squared, is it? So we're likely not going to be able to factor this any further. This is all we can do. That's not an x squared, right? It's like 2, 1, none, and instead we've got a 3 and a 2 and then none. So this is done, and we can't do anything more with it, but we don't call it prime because we still have two factors. We've got this x squared and this big parentheses thing. So this is all we can do. because the other one was prime because we couldn't do anything to it, right? So if you can't do anything to it, then it's prime. If you can pull out an X, if you can pull out a 3, it's still got factors. Not many, not exciting ones, but it has factors. All right? Okay. Any other questions on this for me? Because that's really all this was today. It's okay to save a little time today. It's a nice day. We can all go take a walk outside, not together, distancing. Okay? Summer, any questions from you? Okay. A weird coinky dance.